Alrighty, so now we're going to look at simplifying some radical expressions with variable expressions that are sort of test type or practice kind of things that you'd be expected to do on a test or an assignment or an exam or something. So more or less what we're going to focus on here are going to be things of the type of the square root of ax to the power of n. That's sort of the bread and butter of this stuff. The other ones are a little bit too simple, and we've built our way up to this type of expression. So let's see what happens with that. First one says, what's the fully simplified form of 3y cubed times the square root of this junk? So let's leave the 3y cubed alone and pick on the junk. So we separate that, that's the sort of way that we talked about it earlier, into square root 125 and then square root y to the power of 6. And then we'll just sort of simplify each of these parts and then reassemble things when we're all done. So this gives us 3y cubed times, let's see, square root 125 is square root 25 times 5, I think. 5 quarters makes $1.25. Got that right. And so we've got a square root of y to the power of 6. So 6 is an even power. I just divide it by 2 when I'm square rooting it. So it's y cubed like that. All right, so just got to simplify what's inside those brackets now here. That's going to be square root 25 is 5. So this is 5 root 5 times y cubed. So now we'll sort of reassemble everything here. The only radical part we have there is a square root 5, so that's taken care of. Everything else has to get mashed together. So if it's all multiplied, so 3 5s are 15. And then y cubed times y cubed, same base, add the exponents, y to the power of 6. And it looks to me like that should be the correct answer. And if I jump over here to my multiple choice options, the only one that has that is part A. So in part B, let's see if we can figure out what the distractors were here, what they wanted us to do wrong. Those little tricky devils. So for that first one, they didn't want us to simplify the square root 125. And in the second one there, it seems they wanted us to leave the y cubed alone and somehow get a 3. So some arithmetical magic there. And then for that last one, they didn't want us to simplify much at all. Just sort of divide the 6 by 2. Not much to it. Looks like A is the only option for sure. Let's try the next one. Simplify completely. So here we've got 2x squared times square root, and we're going to split them up, 243, and square root of x to the power of 5. Okay, so the 2x squared we're going to leave alone. 243, let's see, a perfect square factor of that you can try all day, doesn't divide by 2. Dividing it by 3, I think you'll find a nice one, like 81. So we've got 81 times 3 instead of 243, where 81 is a perfect square. And then for x to the power of 5, remember that's just square root of x to the power of 4 times x. Okay, so we're going to have 2x squared here, multiplied by the square root of 81, which is 9 square roots of 3. And then the square root of x to the power of 4, remember, it's just going to give us x squared times the square root of x. And then we reassemble the things that we can. So we'll put the radical parts together. So that gives us the square root of 3x. And then for everything else here, we've got a 2 we can throw out in front. And x squared times x squared, add the exponents, we get x to the power of 4. And it looks like we're in business. So there's our solution for the second one. So the things you've got to be careful about here, things that people get wrong a lot, is often when they do this business, they'll sometimes forget and they'll just pull the 81 out and write an 81 here, or maybe they'll take the 3 out by mistake, all those same things that we pointed out earlier. And sometimes in the end, when you're sort of mashing it all back together, be careful, don't forget your exponent laws. X squared times x squared is x to the power of 4. Simple things that we always forget, make big mistakes. Okay, so don't forget when simplifying square root ax to the power of n, which is really what we're dealing with here, split it up, simplify each one, and then throw it all back together, keeping the like bits in the same sort of group. All right, hope that helps. See you in the next one. Thanks.